with the theme that soil is more than just dirt, our soil actually has these distinct layers that we call horizons, soil horizons. And these are based on their position, where they are, as far as top to bottom, close to the surface, deeper, further down below from the surface, and also their character, color, composition, and what's happening there. We'll talk more about that in a minute. And so think of this kind of as a vertical cross section. So what we're going to be doing is looking at the soil from kind of the side view. So we're just going to cut a big, deep hole into the soil. We're going to look at it now from the side view. What's geographic about all of this? Of course, soils have different profiles, different characteristics throughout the world. We have a geography of soils class that looks more closer at the different types of soils and also where these different types of soils are and which ones are more productive and so forth. Here's a diagram that we're going to be working with the rest of this discussion. And so on the left, this was representing a grassland area, and on the right, a forest land area. And so we would have more of a forest land area here in central and southern Indiana, whereas maybe the northern and western parts of Indiana has a grassland. But much of the Great Plains would be a good example of a grassland area. And so what we see here, we see distinct horizons. So there's the O horizon at the top, and then the A horizon, the B horizon, the C horizon, and finally the R horizon. So each of these have a certain position, but also a certain character. And we'll talk more about each of these different diagrams that you see here. And so come back to this image as we talk about each of the distinct layers on the following slides. So talking about soil horizons, we'll start at the top and work our way down. So we begin with the O layer, and O comes from the word organic. So what we have here is the surface accumulation of organic debris. We also refer to this as plant litter. And so here we have more organic matter. We've got lots of things that have recently passed on, whether it be a leaf, an earthworm, a bug, an insect, a stem, whatever. And so all this organic matter settles and collects, and over time becomes part of the soil, but forms this top layer, this O layer, that's very rich in organic matter. It's a very thin layer. And so of all the different layers that we're going to look at, this would be one of the thinner, if not the thinnest, in most parts of the world. One of the characteristics of this O layer is a certain soil composition called humus. This is a very carbon-rich organic material. I think I've used this humus term before. And so what this is just a very rich material that kind of is comprised of this O layer. And it's definitely going to create, because of this organic material, darker and richer colors than the other layers. Finally, forest land areas will have a thicker O layer because you have more dead and dying things in a forest land than a grassland area. And so we'll look at this more closely at the end, but forest land areas just have a thicker O layer than grassland areas because of the high amount of plant litter, especially. Just below the O layer is the A layer. The A layer is a little bit lighter in color than the O layer, but darker than the layers below. That's because of the higher percentage of humus that would be in this horizon that's closer to the O, closer to the top. So this area contains a mix of humus and mineral particles, and so there's not as large of a percentage of humus in this layer as there is in the O layer, but still, nonetheless, there is a good amount of nutrients and organic matter in this layer, which gives that darker color. This would be the most fertile part of the soil, most fertile, although the O layer is rich in nutrients, which plants love. The A layer provides a little bit more sturdiness for seeds to germinate and then sprout, and for roots to grow. And so regarding each of these layers, the A layer is the most fertile. This is where, like I said, most seeds germinate. So some would say this layer is what feeds the world, because so much of our food comes from vegetation. This is a zone that has a lot of leaching. I'll talk more about leaching at the end, and so we'll come back to that. But A is very distinct as far as having a good amount of leaching. When we refer to topsoil, you often hear this term. Topsoil is a mixture of O and A. And so topsoil is the O, top horizon, and A, the next to top horizon, comprise what we call topsoil. One of the characteristics of A is it contains illuviation at the bottom of the layer. Illuviation, I'll talk more about that later, but illuviation, simply what's happening here is minerals are, in clay particles, especially sediments, are actually moving further down. They're moving down to other layers. And so this A layer contains some sediments that are on the move, and then on the move being they're moving further down. Gravity is pulling them down further. And so one of the characteristics of clay being the smallest grain, the smallest sediment, it collects and is eventually falls to the bottom. And if any of you are interested in drugs, or certain types of drugs, imagine if you have a bunch of drugs in a bag, and you shake that bag, what collects at the bottom? And I often ask my students, and they some of the druggies in the class, and they say, oh, well, yeah, the shake is what collects at the bottom. And so think of that shake as being clay, small sediments, in which at the top is the bigger particles, more of our what we refer to, kind of think of as sands. And so think of the clay, the smaller particles settling at the bottom. And so think of also like in a box of cereal or a box of chips. What always ends up at the bottom? The smallest ones, the smallest pieces inside those bags. Hey, whatever works. In the previous slide, the previous horizon, we looked at the soil layer A, in which it was dominated by illuviation with an E. So illuviation with an E, think of it as exit. So clay particles, smaller minerals are exiting that layer, moving downward to the B horizon. And so in the B horizon is where that sediment and those clay particles settle. So this is dominated by illuviation with an I, meaning incoming to that layer. So this area is going to have very little organic material. That organic material stays up in the O and the A horizons. So this is going to be more rich in minerals. Those minerals, like I said, kind of filter, they work their way down to the bottom, work their way down to this lower layer. But what you really notice here is this is where a lot of clay accumulates. Clay being, once again, the smallest sediment of the four that we looked at. Also, a lot of the smaller minerals, iron and aluminum, also collect in this B layer. And so one of the distinct characteristics of the B layer is what we call clay pan. And so if I try to dig to China right now, I would get through the O layer, I would get through the A layer, the B layer would get a little bit tougher, but then eventually the B layer, I would hit the clay pan. It was, this is where I can't get any further. I'll get to this very difficult layer to penetrate. And plant roots, they don't grow this, they don't reach this way down, this far down into the subsurface because of this very difficult layer, this clay pan layer. So this is going to be lighter than color and above because of that lack of organic material. Often you get kind of this reddish yellow color with the clay. And what that is kind of more of a mixture of iron and other minerals that are oxidizing or rusting, which are giving some of that color to this clay pan layer. When we refer to soils, typically or true soil, or this is the combination of the O, A, and B. And so that's what we kind of think of when we think of this as far as just the entire soil, not the topsoil, but soil just in broadly in general. Wow. Now going even further down below the subsurface, we go to layer C. And this is weathered bedrock, or that parent material. And so this is going to be a good amount of regolith, the term we talked about in the previous exam. And this is just that loose layer of rocky material that overlies underlying bedrock. So there's no organic material down here. This is just a lot of just broken up big chunks of rock that's slowly but surely weathering away, eroding away. So we don't find much clay in this area. This is just a distinct layer of regolith. And finally, we get down to the R layer. R stands for rock, and so this is solid rock, the underlying bedrock. So this is also referred to as consolidated bedrock. This is sediment that soon will weather away and become part of the C layer, the regolith layer.